Hello everyone. Today I'm showing you the preview of my own programming language called Cheetah, and I want to start this video by building the project, the language. We will go into tmpl, and I already cloned the repository from the GitHub. You can do so as well. This is the repository. Now I will jump into temple folder. This is the repository, and I already have created the build folder. I will remove everything in this folder and run the build, and then I will run the make, providing in 16 cores, and you will also see how fast it's building. Let's go. So it will separately build every single node that is supported by the programming language. For example, we have the interpreter side. There is also a compiler side in the future will be available. We have something like function calls, expressions, assigns, casting. This language does support types, which makes it type safe and gives some kind of stability. We have export nodes, we have identifiers, and so on and so forth. So we have also the type checker that first checks for the all code for potential errors and gives you reports, and will not even run your code before you fix all those errors. Now it's already built. I just wanted to show you how fast it's building. Now we will go into another folder that I have created called temple probe, and there is an executable I have copied from this build folder and renamed to Cheetah. Now what we will do, we will copy the standard folder. This is a standard library for this language, beta version. So I will do cp r, and we will go into root, into temple, example, std. No, it's not an std, it's in .temple as far as I know. Let me see. Yeah, so we will copy this from the source, std, and I will copy it in here. So now we have the std folder. The power of this language is that you can connect it to C++ or C and use C functions from this language, from my own language. Let me show you how it's done. So I will show it in here in the UI because it's more comfortable. You first start by writing your target functions. I, for example, wrote 3 functions. First function is to print some line. It accepts arguments and arguments count, just like in the main function of any C or C++ code. And then you can check the argument for the arguments count. You can extract those arguments, cast it to another types, and then use them for your own implementation, for your own needs. And then you can even return some value back to my own programming language. As in here, for example, I'm returning the string type. I'm returning the line from the std input and returning it back to to my own programming language. Now I will, and then it's not enough. You then need to build a dynamic library out of this C file by running following command, for example, gcc. So this is the command you can build a dynamic library with. After that, you write bindings. So kind of a bridge between my programming language and C language. And this is done by writing some code in my own programming language. You do extern. So extern identifies that, hey, those functions should be imported from the dynamic library. You specify how many arguments that they accept, what do they return. You then write your own prettier function. For example, the function inside the C code was called cprintln, and I extern it, and now I write just a normal println function that accepts the message and returns nothing. And all it does is it just calls this function and other function bindings as well. In this example, we are returning the value we've got from the C language. Now it's time to use that standard library, and for that I will again remove it and copy it again from a repository from example.tmpl std, and I will copy it in here. So here we go. Now I will start by writing my test.tmpl. I will call it main.tmpl. Let's do it like that. What I need to do first, I want to import this file in order to be able to use print function. We do add require. This is the command to import some file, and then you provide std. So you provide the path to the target file you want to import without providing the extension. So this is the path to that file. As you can see, std io.temple. Now what you do, you create a new procedure. You do that by writing arrow to the right, and then the name of the procedure. The default procedure name is main, so I'm going to use it as well. And then inside this procedure, so the procedure is just like a function, but this is a function that you can call directly from the command line. I will show you that later. Now we will create some variable of type string. I will call this variable message, and I will directly assign a value to it, something like hello world. Yeah. As usually you do in any programming language, when you're learning something new, you write hello world application. Now I will run function from C. So I will call this function, and this function is exported. That's why I can use it in another files. This is important. If you don't export your function, they will become private, and you will not be able to import them from another files. Now we call this function by specifying its name and providing in the arguments that it requires. In this case, it requires only one string argument. I will provide in my variable that I have defined 2 lines earlier, called message. I'm providing this variable inside, and not forgetting about semicolons. Then I am finished. Now I want to run this. How do I do that? I save this file and quit. Let me clear the console. Now we run our executable that we have built in the beginning of that video. So this is the interpreter itself. I called it Cheetah for now. If I run it without providing any additional arguments, as you can see, it says that I have not provided enough additional arguments, and this is the usage of it. So you specify the script. The script is the name of the script placed in it can either be placed in .temple folder, or you can provide a full path to the script. So in our case, it's, as you remember, main.temple. So we will provide this as the script parameter, and then there is additional not really required argument is the procedure. So this is the name of the procedure inside the script that you want to run. In our case, we've had only one procedure called main. So this is the procedure we have, and I want to run this. The thing is that you can provide this main as procedure argument, or you can leave it empty because the main is the default procedure name to be run when you try to use this programming language. Let me run my code. I'm running the executable, so my interpreter, providing in the path to my temple, to my code I have written, and then after that I can specify procedure name that needs to be run. Let me do so. Now I press enter, and as you can see, there is a message, hello world, some additional debug messages for development. This project is still in development, that's why there are some messages, some debug additional messages presented. Now, the same way it would work if I didn't provide the procedure name, because the procedure is called main and main is the default procedure name to be run. I can define another procedure, for example, by, I can call it by, and I can again create some variable, for example, or directly call that println function and say hi. No, in this case we want to say bye everyone. So bye everyone, and then we quit. And then in order to run this, we need to provide in here. So if I will not provide the procedure name, it will still run the main procedure. I want to call the by procedure. I'm specifying the name of that procedure, press enter, and there we go. We have now by everyone message. Now what if I want to get some input from the user that is running the script? It's also possible, because we have this function defined in here in the standard library called getLine. This is the native C getLine function that you can use. I miscopied it. Let me undo that and insert it again. So this is another procedure, another example of using getLine function. It's called ask name. We asked for the name using the print function, so without the new line, and then we are creating string variable called name, and we're capturing the input from the console into that variable. Then we're printing that name, so that variable we've got from the console input, we're printing it formatted, wrapped with a nice message like nice to meet you, and then the name itself, and then we return the name just for the debug information. You will see that later when I run the code. Let's actually run it. I'm running it, specifying procedure name. It was ask name, as you remember. I press enter. It asks for my name, and as you can see, it stays in this state, indicating that hey, you need to type something. I will type in my name. I will press enter, and as you can see, we get the message nice to meet you, and then my name, and then the new line before the exclamation mark. Why? Because this is the cGetLine function, and the cGetLine function captures the new line character as well. And you might spend additional time either rewriting the cGetLine function, or doing additional logic in my language in order to remove that new line at the end. But this is something that you want to do. And then we have the debug message. We have evaluated the procedure, and the procedure has returned a string value with the value and my name, and then the new line again. So this is my language. It has a lot of possibilities with the help of C and C++. In the future, it will support more, and it already supports a lot of things. There is under this path, you will find a lot of examples of defining functions, of writing vectorial functions, of escaping the strings, of writing some dumb std, of casting types, of assigning some variables. As you can see, you can assign the variables, you can print them. There is a casting. There are also type functions. For example, we are defining the integer, our own integer type that extends the native integer type. Then you need to write a constructor using function abbreviation called construct, and then you need to write the target type name you want to build the constructor for, and then you provide the arguments that this constructor requires. So this is just like classes in any other particular language like Python or JavaScript, and then you return this type, the type your target type extends from. This way you have the this way you have the target type. You can now build variables with this type. You can then define another type that is extending your already defined type. So for example, I have created integer that extends the native int type, and then I have created a type number that extends my own integer type. And then the same way I wrote the constructor for that, it accepts the int value. I might have directly accepted the integer type, but I decided to do it to accept the int type, so it's easy to build this type, easy to build variables with this type. And all we do, we just build an integer out of this int, and we return that integer. And only in this way you will be able to construct this type. Then we are writing the cast from my own number type to the string. And all it does, so this is the casting math. You take the self is of type number because you're writing the cast function for the number type. You cast it to integer. Why? Because the integer can easily be casted to int. You cast it then to int, and then the int can be casted to a string with the help of std_convert function that has this implementation and supports converting integers or floats or doubles to the string. You convert it to string, and then you return your final value. This makes it very type safe and very stable. After that, in your main procedure or any other procedure, you can use those types. For example, I'm defining the number 100. I'm printing it because the print function only supports string arguments. We're casting that number to string, and this is possible because we wrote this casting in here. If I had removed this code, it won't be working, and we would get an error. And then at the final stage, I'm just printing some hello world message. So those are the type functions. This programming language has already a lot of possibilities. It has a lot of usages and is easily extendable. And if you want somehow to contribute on that project or see the future for that project, then please contact me. If you want to help in your own project, something similar to this, where we inspecting, exploring something new, building some new software, then please contact me. I am here, I am available. Thank you for the watching, and I wish you a good day.